Welcome to Lecture 14C, Series 2 for LabVIEW. This is Session 3, Documenting Software Code. This is the final lecture for the course, and we'll be wrapping up software code in LabVIEW systems with documentation and an example to go along with it. Quick words about documenting virtual instruments or VIs. Some comments we're going to go through. Obviously, they're the easiest way to document what's going on in the window. Customize icons using the tool palette, giving you contextual help messages. We've talked about that, flying over the mouse with Ctrl H, putting your mouse over any block diagram or any structure will give you a quick help, and revision information. These are various tools to document properly RVIs. So words about software development in documentation for designs in the mechanical part of the course, the first module. We documented designs on the 2D drafting module of NX, for example, and that's widespread throughout that industry. If you have software code or instrumentation like we're setting up here in Module 3, a common historical approach is to maintain design documents and source code separately, and this is difficult to keep these type of documents up to date if customer needs or code changes. So a practical approach for you in LabVIEW will allow you to do this, and you should do this in any code you write, is actually add information as you write the code, update source information, understand why the customer or the user needs an input changed or whatever that input needs to be. And of course, recent software and LabVIEW has tools to generate design documentation from the latest source code and graphical interface. So just a quick example, I'm going to bring up a supplement file. You can find that in the downloads on the supplement section in LMS. And this is just a program that counts down from 10 to 0. In the program, it's using a while loop, so it compares if the value that it's currently at is 0 or not. And if it doesn't, it'll just index the counter up. So 10 minus 1 is 9, 10 minus 2 is 8, and 8 is 8 equal to 0? No. And the loop keeps running until 10 minus 10, of course, at the 10th iteration is 0. And we put a little wait indicator here to visualize the countdown. So if I run this, you can see it goes from 10 to 0, and it happens pretty quick. If I didn't have the counter in here waiting 100 milliseconds, you'd probably not see any number except 10 or 0. And the light just shows a Boolean indicator that it has reached the end. So if I run it in one single loop, it'll stop at 0 and the light will turn on. If I run it continuously, it'll just keep resetting itself back to 10 and running down to 0. So we'd like to comment this code in case nobody really had the benefit of having a verbal description like you do. And so we use the tools palette here. And if it's not up for you, again, we saw in one of the National Instruments videos, you can view the tools palette here by going to view, and the comment in edited text just adds a text box here. We can say starting value here, and you can just simply add a comment in and add other comments in as well. So we can type in what these various boxes are doing, and you can go back to moving them in the position you want. That is how you add comments to the code. Of course, we talked about Ctrl H in the context help before. We put our mouse over certain things and it'll give us what those functions are doing. And let's take a look at documenting or printing our VI documentation. So in this, we have now created some comments here. We'll go into File VI Properties and various categories here. In the general, we have the option to edit the icon, and that'll bring up our icon editor where we can play around with the paint tools over here and change what the icon looks like. I won't do that right now. We have a revision history, and we can look at what revisions were changed. And if you had a change, like I have before, I'm on revision 2 now. The first revision, I changed the word numeric, which would have been right here, to countdown. And in this change, we added some comments. So I can add that in, and I can say OK, and then I have a revision history of everything that was done on this, and I can continually update that for any future user coming in and looking at my code. I also have a documentation tab. I can give a VI description, so I can type in whatever I want here, a meaningful description for the part, and hit OK. And of course, I can file save that again. And once I do that, you'll see that my revision history has updated to number 3. Now we're ready to, let's say, print documentation. If I wanted to print this, we would like to have our documentation. So we'll print this VI. So we'll go into the next panel. We'll do the VI documentation, and we'll see what that entails. Looking at a custom, we can get our description. We can get the block diagram, of course, and we can get our controls if we want to. And we can go to next, and we can print this as a RTF file, HTML, or go to a printer, whatever you want to do, and click next, and we will save. And this will ask us to save it. And we'll just bring that up here to take a look at it. And I'll pull it over here so you can see it. And there, of course, there is our documentation with the description that I typed in. Our front panel, it comes in as a picture. So we can change this, of course. We can go to wrap text and make it square so we can move it around. And we can have that as a documentation or figures in our report. Or presentation. So to finish up, so there's some other style guides out there for National Instruments. They are linkable in the description. Just to show you what they look like here, I'll pull the guide chapter up here. You can get a direct link to this, and it looks at some other colors and styles and some best practices for that. And of course, the style checklist here, again, linked in the description. You can take a look at certain checklists to see if your code is up to industry standards as well as National Instruments has provided them. Other programming documentation standards for not just LabVIEW but MATLAB and code in general. These are very good sites. Again, check out the links in the description. And that will conclude Lecture 14C and the lecture series on engineering communications.